All yours.
Okay, welcome everyone, thanks for coming. I said to Nimrit a while back, I had a kind of a little idea that was worth sharing maybe with a group of Java people in locally. This is a kind of perfect audience. So this is not really a whole talk, it's just kind of a bunch of ideas that I've thrown together on a few slides. Probably a kind of obvious question, any Java developers in the room? Any C developers in the room? Who writes in C except me?
Like in the past or
good.
right now?
Well, either right now is more relevant to me, but in the past. How about people who need to do some C in a Java predominant build? No? Has anyone ever used the Java native interface? Is anyone ever? Okay, so that's kind of where I am. I have mostly Java code, but sometimes in the line of work I do, I've either got to bind to a C library or I want to bind to a C library, so I don't want to rewrite a bunch of logic in Java, or there's just things I can't do in Java that I can do in C. And because of the Java native interface, it allows me to bind my mostly Java code to some C that I need to do. So I work at APL, at the UW, I'm on various projects, and one of those is cyber security tools. So writing tools for cyber defenders, so kind of disk host-based forensics, lots of kind of low-level stuff where you're going to need some C code, but I want to build most of my code in Java. So I've come up with a kind of recipe that I use, and maybe people would want to use if they're in this arena, to basically make most of your product build Maven-based, live in the Java world, and only touch C and Makefile stuff as little as you can, as little as you have to. Oh, I think I skipped that. So an outline of what I'm going to waffle on about is my local need for Java native interface. I could think of 3 projects I've got where I've got Java code base, I've got some C, and I've got to fuse the two together. Okay? And I've struggled around this for years thinking, what's the best way to build these things as a unit? Then I'll just dive into Java native interface basics. If you've never seen JNI, this is basically hello world for JNI. It should take 5 minutes. And then what inspired me for all this was this thing called Snappy, which I'll introduce, or Snappy Java, which I'll say what that is. And then that inspiration led me to do step 4, which was generalizing what Snappy did so I can go back and revisit my local need and organize 3 project builds along a kind of controlled build, not just an ad hoc way of doing things, which I had struggled with for a while. So, when I say local Java artifacts, projects that I work on that have mostly Java and need some C. Okay. I seem to be obsessed with parsing file formats. You give me a file format, I'll try and write a parsing format. So, I work with virtual machines as test beds for cyber security tools. Is anyone familiar with virtual machines? BDI files, BMDK files?
Can I ask a question before you?
Yes.
How does security relate to applied physics?
There's a lot of software people in applied physics. And we're looking for money from wherever, and DOD and DHS are giving lots of money to cyber security. So I logged onto a project that was cyber security, coming at it from a software engineering standpoint. So I work with virtual machines. I wanted to know about VDI, VMDK files, and exposing the content of those files. Basically, getting at the content of those virtual drives while the VM was powered off. And so I built some Java code to parse those files. Then I wanted to get host tools to run over that Java parser. And a great system for that is Fuse. Is anyone familiar with file system in user space? Yeah, so you can expose any file content you like in a user space program. It works on Linux and on Mac. So that was one project where I wanted to add Fuse for J. Someone had written Java bindings with JNI to the Fuse C library. So I kind of cloned that, looked around at the way the guy was building the code, and it wasn't that organized, so I tried to kind of apply my recipe to that project. SleuthKit is a digital forensics library written in C for basically independently understanding NTFS, FAT, Mac file systems. So basically, you walk up to a dead file system, i.e. one that you're going to boot off a CD because you trust the software on your CD, on your boot media, and without mounting a file system, you're going to be able to walk an NTFS file system find all the files, find all the deleted files, do file carving, stuff like that. So sleuthkit's great for that, but again, that's a C library. I want to make sleuthkit a part of a bigger program. I've got a mostly Java code base, so I developed TSK for the sleuthkit Java binding. So again, I've got mostly Java code, but now I'm binding to a C library, so I need some JNI, so I need a way to organise my build. And then Tupelo is a local project we're working on, that's cybersecurity tools, and I'm working on host-based forensics. So how do I want to image an entire drive over time and store it somewhere so I can go back and search that stored copy. So I've got to accurately identify disks. It's no good saying Stuart's disk, because if I take 100 drives and try and store them all, I need something unique to each drive. So something unique to a disk drive is this vendor serial number. So you can read that in C, you're not going to get any Java code to read a disk drive serial number. So again, I'm in a mostly Java world, I need some C to play on me out the things I can't do in Java. So for all those, they're all Java code bases, and I'm a Maven fan, and I know Make fairly well, so I've got this Maven-Make problem of joining the two. And I wouldn't say you can really solve this problem, I'd say you can work around the issue of needing some C build in a Maven and Java-based build. So, like I say, I flowered around for ages and finally thought of a sequence of steps to do a build that can solve the problems I've got. Any questions? So flames, and anyone can say at any time. This isn't meant to be one way in any way. So Java is built once, run anywhere. C is most not that. Okay. C is really you build it for one platform, and then you have to build it for another platform. But what I really like about Maven and why it's leaps and bounds better than something like Ant or an IDE that isn't really modular, is that Maven encourages you. We got Maven fans in the room, hopefully, or is Maven probably last year's thing now? It's all great. I love Maven. So it promotes reuse. You hear about reuse by inheriting classes. That's all in the small. You need something powerful like Maven to promote reuse in the larger scale. So if you build your units of work, Maven artifacts, and you can get composition of smaller projects into bigger projects by dependency management. Maven's so good at it. Okay, so that just falls apart in the C world. You're kind of on your own. There's no system I know, especially for Unix C, Linux C, other than Make, that can promote what Maven can do in the Java world for modularity. So I've got this mismatch where I want to go Maven, but I've got to somehow accept that I've got platform-dependent builds. Is there a pointer anywhere? So what I could do, if you think of Maven artifacts are triples, you identify your group, your artifact, and your version. That's the way you provide your piece of work, your effort into the whole Maven universe, if you like. Well, if I inject into the name somewhere, i.e. into the artifact, I could say, really, this looks like Java code, but it'll only work on x86 for Linux or 64-bit Linux. Because there's compiled C code in there that'll only run on one platform. It'll run on one OS, and it'll either run on 64 or 32-bit. But it won't run anywhere. So that's what I did. I was trying to tag my jars, my Maven artifacts, with the identification of the C part of it. Okay? But the problem is that doesn't promote modularity and reuse at all. That hampers it. Because if you've got this artifact, and it's a library and not a program, and now you want to build and use that as a dependency in a bigger Maven build, now you're tagged with being platform dependent in the larger thing. So once you're tagging something dependent, everything that uses it is platform dependent, and your modularity kind of falls apart. You start exposing, yes, Nimrod.
Sorry, how many platforms were you targeting with those libraries? Is it all just Linux, or is it?
I mainly build for Linux. I did some stuff for Mac, and I have to go back and look at the sleuthkit one for Windows because I want to put that up on GitHub.
Okay, so
it needs to be more serious, and if I get to do the Windows build, it will be. I've got some Windows tools. So, okay. So, going back to that last point, if I've got a Maven artifact called mylib, and I say I'm going to have to tag this in some way to say that it's x86 code in there, then if I depend on that, now I've got to tag my bigger app. So this is just going to be a mess. Okay. But that's what I believe for ages to be the only way to solve this. And that's what I was trying to do. And there's a plugin for Maven. Anyone familiar with the native archive plugin, the NAR plugin? It's a kind of attempt in the Maven land to address this, actually to do C builds from Maven. So rather than use Make, somebody thought, well, I like the aspects of Maven, dependency management especially. So I was kind of influenced by it and tried to dabble with this NAR plugin, never got it ready to work for the split language builds that I want. But that was kind of a dead end. So that was my need and my attempt to solve it. So I'll now give you a quick summary of J and I in 5 minutes. So if you can't do something in Java, this is how you do it in C. You go into your Java classes and you say, I can't do this method in Java, I'll do it in C, I'll tag it as a Java keyword in native. Okay. And then I'll need this code to load the library that I'm going to build in C. This basically says once you've found and loaded what's called a shared library or a DLL on the Windows platform, then the C code that's in this DLL or shared object library will contain the adder class and the static sum method. Can anyone see the joke on that slide? Meant to be a joke, humorous? Yeah?
Java cannot do integer addition.
Thank you. Right. Java can do it, yeah.
Supposing it couldn't. Right?
Supposing it couldn't. If it couldn't, if this was read a disk drive serial number, so Java can do addition. But imagine it couldn't, that's what you do. So this is your first step. Identify the native methods in the Java class. Other than that, keyword there in red, that's pure Java, as you can see a billion times. Maybe not use this called the Java lang system. Okay, so that's what I do to start off. And then I build that, so if I didn't have Maven at all, I just went back to the command line, Java C, dream up some package, some file system structure. So if I put my things under source, use the package hierarchy as I'm sure you know, and I'll stuff everything in bin. So I say -d, bin, into the command line. So fairly straightforward. Don't put your generated artifacts where your source code is. Okay. So I built the Java. When I've built the Java, I've got a class file, obviously. And now I generate a C header file using a tool in the JDK called Java H. Okay, Java H actually does not use source code. Java H will climb through the class file, identifying the native methods. So you give it a class path of bin to tell it where to find this class. You don't give it a source file path at all. So the invocation is Java H -d just tells me where to put something, so I'm putting my C code in a C directory, class path of bin, and the class to find the native definitions in. Any questions on that? That's fairly straightforward. Java H is a tool that you need, yes?
So is there in the previous class where you were loading that native library, is that global or is that specific to that class?
Is that there global? This will be a shared library that hopefully will be and I want it to be in the jar at runtime. It could also be accompanying the jar. It doesn't really have the notion of global scope.
I just wondered if you had two C libraries that had the same method signature or something, how would Java be confused about which one of those?
You would want one C library to take responsibility for implementing one set of native methods. You could split that between two C libraries, but you wouldn't want a name clash, because that would be a recipe for disaster. Okay.
I think we're getting to the point of what if it's a 64-bit library versus the 32-bit library?
You need two different builds of the C code.
Yeah.
And
Would produce the same library name.
We'll produce the same library name, if that's what you mean, yeah. I don't want to be editing my source code. That's one of the big things I haven't got on the site. I do not want to be editing my Java source code for my different product platform builds. That's a good point, thank you. Okay, so Java H builds me this thing, a C header file, and names it accordingly with the package and class name that it found. If I look at that C header file, so this now, we're not in Java anymore, we're in C. So this is an auto-generated file. It tells me that in a comment. JNI.h is a standard header file that comes with your JDK. There's a big comment here saying what this is. And this rather yucky looking thing is the signature of the C method that I have to define. So this is just a macro. This is C's notion of Java's int as defined in your JNI file. Not quite sure what that is. This is the name mangled thing. So CJO had a sum tagged on with Java. So that's a valid C identifier for the name of the method I have to define, Nimrod.
That's namespacing. C doesn't have namespaces.
Yeah, I call it name mangling, but yeah, it's effectively namespace. Yeah, it is. It's namespacing. You're right. So, and these are from the Java that add two ints in natively, and from the sum method, they're the two ints that will come in when the Java code calls the C code. Okay, so it's my responsibility or your responsibility in JNI to implement that function. And the tool is giving you the signature of the function, so you know you're going to write the right method definitions. So when the library is loaded, the Java VM can find the C code that it needs. Okay, so if I was going to write that, that's all it is. I'll just include the header file given to me. I'll copy, I'll cut and paste out the header file the signature. Rather than it being a C declaration, it's now a definition, so it's got value races, so it's a valid C function. And all I'm doing, of course, which I could have done in Java, is adding the signature. Okay. But imagine that you couldn't do that. So that's all my Java code written, that's all my C code written in the JNI world. So I've got to build that C code. So imagine that I'm building and I know my Java home is some JDK, Java 7. If I'm on Linux, I'll use GCC, GNU C compiler. I'll compile only to object code, all my source code, and I'll have to include, as on the include path, the include directory to find the JNI.h. When I've built all the .o files, I just throw them all together in a shared object library, which on Unix is called lib, and then the name, and then .so. I'm sure you know if you're a Unix program. If I was on Windows, and this might not be exactly right because I haven't done this for a while, CL is the Windows, Microsoft command line invocation that you get from Visual Studio or Make. So the same kind of approach. I've got to find the header file that comes with the JDK on Windows, and I'll throw it all together and I'll get a DO. So that's the two builds you have to do for two wildly different platforms, but the C code is simple enough that it's actually the same code. I haven't got Windows specific C code in that case, and Unix specific C code in that case. I was kind of lucky in that how to add two numbers up doesn't require any platform dependencies in C. Okay, so now I run the program. Well, even that's not that easy, because in Java land you have to say exactly where your C libraries are so that the system load library call can locate the .so or the DLL. So easiest way to do that is this macro, this, whatever you call these -d things, environment variables or whatever. What do people call the -d things in Java?
System properties.
System properties, thank you, Aaron. System properties, one of those is Java library path, and then I've got my regular Java class path, and my entry point is CJO.h. Okay, so if I do all that, and I say build it on 64-bit Linux, it's only going to work on 64-bit Linux. But that's the basic tour of JNI in 5 minutes. That's how to fuse Java and C code together to get a mainly Java program to build and run. So, what have I done there? Well, I just decided on some homes for the Java and the C code. You have to make sure that it's not me running my program, it's me delivering my code to some customer or to somebody who want to run the code. So now I've got to worry about the distribution. So I've got to bundle my Java code. Well, that's easy. Maybe it's going to build me a jar, or I can use an assembly to build a zip of different jars if I've got dependent jars. But now I've always got to tag along the C code in the .so or the DLL, because without that, the code that's going to do the system load library is going to bomb with an unsatisfied link error. So What you really want to do, of course, that you might be thinking is throw the C code in one of the jars, and that's kind of what you want to do. Not trivial to get it to run from there, but you certainly don't want to be distributing many files together such that someone could lose one or misplace one or put one somewhere that won't work. So the Java side of all that, Maven's just staring me in the face. But the C side of that doesn't really, in my experience, have a satisfactory answer. And what do I do about platform dependencies? Do I tag my Maven builds with platform dependent stuff? I'd like to not do that. And this is where I was for ages, thinking I've got all these projects, I haven't solved it. And then, completely unrelated to that problem, I had to write some code, and I wanted to write in Java because I'm a Java fan, and I had to consume from a web server some data that was compressed in a compression algorithm called Snappy. Anyone ever heard of Snappy? Okay, gzip, you probably know gzip or winzip or whatever. So Snappy is a compression algorithm where the big advertisement for is it's fast. It's dead fast at compression and uncompression. It doesn't claim to be as tight space-wise as gzip, but it can do the job quick if you don't care about the size. Okay? So whoever had written this cybersecurity tool that I was trying to get data from, they'd chosen Snappy. So they'd done Snappy compression, I had to do Snappy decompression to understand the data. So of course you think, well, he said he's using Snappy and I'm using Java, so you go to Google and you Java, Snappy and Maven, and you hope you come up with a Maven artifact for the thing you're trying to use. If anyone knows how a better search that you do online, then I'd be all ears, because I just go Google and I say Maven plus X, hope to find X as a Maven artifact on Maven Central. So what came back was this thing called Xarea or whatever. It's on GitHub. There's the source code and the Maven artifacts. It was called Snappy Java. And Snappy Java said, we're wrapping in JNI. If you ever see the word Java wrapper, it means JNI. They're taking the C++ code from Google that is the original Snappy compression algorithm, and they're just Java-ifying it. And I thought, well, fair enough. It's a JNI build. It's not rocket science. But what struck me was the artifact name for that was this group, this artifact, this version. And I immediately thought, how come that's a Java C build with an artifact name with no platform dependency identifier? That really struck me as different and exactly what I needed to go and revisit my lousy project builds that I've been doing. So immediately I climbed into the Snappy Java code base, looked at the source, looked at how it organised stuff, and thought, oh, this is just so where I should be. So if you look at the Java Snappy jar, it looks something like this. They've thrown all the platforms they ever want to expect to run on in one jar. It's a regular Maven artifact. Okay? They've said, we will run on Windows, we will run on Sonos, we will run on the Mac, we will run on Linux 64 and 32-bit, we will run on Linux ARM. They've spent the time compiling their C source code into a shared library for every platform they expect to run on. And they've stuffed all of that in a single jar. I don't know why I had never thought of that, but I had never thought of that, and that was a great thing to see, so I knew that would solve all my problems. So they approximated a C shared library with the path structure in their Maven artifact. It kind of approximates a Java class. You can think of this as the package name down to the individual class, then they've used a keyword native, and then introduced their platform-specific stuff, their OS and their Arch architecture, and then hanging off at the end, and the resource name is the actual C code that you need to load. Okay. So the genius of that is all their platforms are in one jar, and there's no platform identifier in the jar name. So what if that jar is big? Disk is so cheap and development time is so expensive that the time saved with not building that code for many platforms is such a win. Okay, so what that jar is 2 megabytes. Okay, so now we're looking at compiled C code really as Maven resources. And what they've done, and I've used as well, is that once one person builds one platform-specific library, they just check it into Git or into source control. No one ever has to build it again. It's as though it was a resource under source main. Okay? That's quite important as well. You don't want, in a Java, if you've got a Java team and you've got some C code in this build, you don't want all the Java devs on the team to need all the C compiler tools. You want to treat that as a kind of build once per platform and then check it into source control, and everyone else just gets it in source main resources and they put it in the jar as though it was just an image or a ping file or some text file that you wanted to load as a resource. Question?
Previously, you used a system property to tell the JVM where the C code was. Now that it's in a jar, how does the JVM load that?
We'll come to that. Good question. Okay. So what the features that snappy Java code has got is, as you've seen, they bundle all the platform-specific resources in the single jar. They have a class loader in the code that knows how to find, it knows how to look up what platform it's running on, because you can use system properties for OS Arch and OS name in Java, and then they take that information and they go hunting through the jar, just doing resource as stream, which you might be familiar with, class loader, get resource as stream, to find the resource name and then pull it in. And then, unfortunately, you can only ever load C code in a Java VM from a disk. You cannot load it straight out of the jar. You can extract it from the jar, and their class loader does that. I say class loader, it's not class loader. Their native loader class extracts from the jar the resource they need at runtime, having identified the runtime platform, stuffs it on the disk somewhere clever, such that it doesn't impact the disk after the program's finished running, because that will get cleared up. And then they say, then there's a Java lang system call to load a shared object library into the Java program from the disk. So to all intents and purposes, from the user, the C code is buried in the jar, just like the Java code is buried in the jar. Question, Eric?
If you're using OSGI, introduce an additional attribute you put in your manifest, and all this happens automatically.
Ah, good. I didn't know that. I'll have to talk to you about that. I did see OSGI when I was looking at the JNA technology. Okay. So, I looked at the snappy Java loader and looked at generalizing that so I could apply it to all my projects. If you come up with so define a class called native loader, and the only thing I want users to ever call is load, passing it 2 parameters saying some identification of the group and the artifact name. So what I've got to do is find the native library, and that will be, like I say, a function of getting the current OS architecture and the current OS name by looking up system properties. And then building a resource name that matches how I'm going to do the builds. So I'll put the group in, native, then the info that was the OS Arch and OS name, and then the native library name. The native library name is a Java lang system call called map library name. If you give it foo on Windows, it will return foo.dll. If you give it foo on Linux, it will return libfoo.so. So you don't have to worry about knowing what platform you're running on or the shared object library name. This static call here will do that for you. So basically, that was just a generalization for arbitrary C code that I kind of stole from the snappy Java code. Okay. So maybe that's just what I said. I use system map library to do a conversion, so I don't have to know the platform file name, the DLL or the SO. I use OS Arch and OS name to know what platform I'm running on at runtime, because obviously I've got to know that to identify the resource in the jar. And I just build a resource path to climb down the jar to identify the right code for the right platform that I'm running I just throw that on the file system and then ask system mode to load that. So the user never has to know that, and all the C code that you need is buried in the jar. So you have a reduced footprint for your distribution. Okay. So to use that class is literally as, if I've got some class with native methods in it, I just give it a name and some artifact name, and it will find for the current platform, the operating system and the hardware architecture, the right DLL or .so file. So basically this can load me all the C code my with native methods class is ever going to need with just one line of code. Okay. So that was my step one of my recipe, was defining a generalized class loader, C function class loader. My step two was thinking of a file system layout adhering to Maven's standard directory structure as much as possible. So at the top is obviously the POM. My Java classes go in regular places, and my test cases go in regular places. Source main native is where I put my C code. If I'm lucky, the C code might be completely platform independent. I mean platform independent, it doesn't include any Windows files or any Unix files. The code that it produces is obviously platform dependent, but the source code may not be. So if you're lucky and all your C code is simple enough, it can be put in one place, you put it up there on the native directory, okay, and you may have test cases as well. If the C code is platform dependent, probably have to put it in the operating system subdirectory, and most of the make stuff will be in here, because an 64-bit make for Linux is likely to be mostly a generic make for Linux with maybe some CPP flags to say certain types have to be 64-bit wide. So if I'm really unlucky, I might have C code completely dependent on the hardware architecture, but mostly if I've got Linux code or platform dependent code, it will go in there and not in there. So then I have a make file in each directory for each OS and architecture, same for Mac and Linux. And then what I produce when you do the builds from the make, I'm going to get Maven to call the make, and I'm going to get make to put the artifacts, the SOs, the dilibs in source main resources, and then I'm going to check that into Git or its version control, so it looks like a regular Java resource, even though it needed the make and the C stuff to create those. Okay. So I had to split the POM up into various parts because it's quite long. So the first stage was, I want to do the Java H step, produce the C header files in Maven. So how do I do that? Well, there's something called the native Maven plugin from Codehouse. So I'm going to bind that plugin to my compile phase of my Maven build lifecycle. This is the goal. I think it's a single goal. And I'm going to enumerate all the classes that I want that Java H plugin to locate and produce me header files for. Okay, so that's the Java H side folded into Maven. And then further on in the main POM, I'm using the exec plugin because I'm going to call make. So in the compile phase of my build lifecycle, I'm going to use the exec Maven plugin and the exec goal, and I'm going to configure that such that it runs whatever program I want it to run. In this case, I want it to run make, but really this should be some system property enumerated from a profile to identify the platform that you're running on, because I can't call this on Windows because it's probably called nmake or something, or Visual Studio, some Visual Studio tool. So the working directory I want to be in, given the file system directory structure I've just shown, I want make to run in source main native, and this is Maven finding the OS name and the OS arch. So that is kind of platform independent, which is I want the Java side of this and the Maven side of this to be, because I want to be heavy on the Maven end. And then I'm just going to pass the make file, the make build, to arbitrary strings that it can use to build the shared object library. So I'll just read, this is from the Tupelo security stuff I was working on. That was a Java package name. and then I've taken the artifact to be the same artifact from the Maven build itself, from the Maven project. So that's now how to get Maven to call make in the right place, and the make will contribute the platform-dependent components of the whole program back to the regular Maven directory structure that we know under source main resources. So my make files, the bottom of my tree is my operating system and hardware architecture make file. It's just very easy. You just have to identify what platform you're building for, 32 or 64-bit. So this is the rest of it's the same. And we're just going to include from the Linux directory itself the main make file. So that's where I would build. That's where Maven would CD me into to run make. But most of the heavy lifting is done in the Linux make file, but not the Linux 64-bit make file, which is there. So then the main make file is a bit more complicated, and it's a C make file, but it identifies enough. I need to locate my JNI headers so that my C code can build. I use some tricks to find all the main sources, so I don't have to enumerate them all by hand. And then the thing where the build and the make main target will run it's saying it's the base directory is where the POM lives. So source main resources, and then the package name that I passed in, which had dots in it, so I'll just convert that into a path structure using make substitutes as GNU make. So given that kind of template, it hasn't got a lot of project-specific stuff in it, in fact hardly any, because it's all passed in by the Maven in. In fact, looking at that slide, it doesn't have any project-specific stuff in it at all. So it's applicable to any of the projects I wanted to use that recipe on. So that's the make file to produce me the stuff to go in the main Maven directory structure. So to do that, what I didn't have space for on that slide was, if you had that in a kind of vanilla structure, every time anyone tried to build that project, they'd be climbing into the C side of things, and if they didn't have the C tools, that Make's going to blow up. So what you want to do is you want to wrap the Java H generation, and especially the make invocation, in a profile, in a Maven profile, so that only the power user that does have all the C build tools is ever exposed to Maven trying to invoke those plugins. That was a good use of Maven profiles. So if I define all that stuff that I just showed on the last two slides in the POM inside a profile called native, and if I want to build the Java code and the C code, I just invoke Maven with that profile name. And then I actually add to source control the parts of that build that the C code contributed. And now, even someone else on the team that could do the C build doesn't have to, because it's essentially built for them. Okay. So then if I package it all up and look at my artifact, I've got the resources adhering to that path structure that I want, the native loader can build. So I have a responsibility of the make process, the build process, has to align with what the native loader code expects to find or wants to find in the Java. Okay. That's about all I have. Snappy Java kind of made me see the light in how to do all this. I'm going to hopefully put this up on GitHub as something that someone else could use, if there's anyone still in the Java C split language build structure. And if anyone else wants to talk C builds, if anyone's in the C code base like I am on a different project, pure Unix C, Linux C, wants to look over the Maven fence saying, wouldn't it be great if we had all the Maven build tools, the Maven dependency management, how to organize code bases in Java using Maven, but we're in a C world where Maven doesn't really fly, and I've developed working on something called Maker, which is so if anyone wants to, if anyone's interested in C build, and would like to use Maven ideas, then come see me. And that's all I have. Any questions?
That make and from where it's gonna grab the dependencies. You plan to have
From a
your-
Maven repository that you build up on your local system.
Okay.
Pure C. And what the other thing I needed that for was cross-compilation. I test on x86, but I run on ARM. So that was another facet of that Maven couldn't do. So it wants to be, it's pure make files organized so they look somewhat like stealing some ideas from Maven. But it's not Maven in any way, it's Make.
Just out of curiosity, did you look at Gradle at all? And the only reason I ask is because Android uses Gradle, and they sometimes have to deal with native stuff. So I don't know if you looked at that. Or
I haven't. I mean, I don't kind of work on this all the time, so there's probably a whole, and just researching this in the last few days, there's a technology called JNA, that wraps JNI. There may be other better ways of doing this. This is just what I had been doing.
Yes. You want to say something?
No, that's what we're.
Are you guys dabbling in that space?
Yeah.
I don't dabble in the Android space, unfortunately. But hopefully some of this may be applicable somewhere. If you've got C requirements in a Java code base, this is one way I found to solve it. Eric said there may be something more streamlined to do it.
I think he was talking about OSGI before runtime.
Yeah, but it's more of a runtime solution. You build it's going to be more painful.
See, my goal really was to turn, not to just build a Java program with C parts. I want to build a Java library with C parts to use in bigger programs. You know, anyone can write a Java C program, but can you organize it so that it sits in the Maven universe of artifacts that can be depended on to build bigger programs? That's what really I think this kind of lends itself to and does kind of solve. At least it solved it for me. I can now look at my Java C builds and I've got this structure of how to lay out the file system, how to lay out the make files, and how to do the native loader to know that it will all work and produce at the end of the day the jar given the restrictions of how many platforms I've compiled the C code for, like the snappy Java guy did. So that it does all kind of work as a unit. And I don't know if the OSGI solution is addressing that problem. Question?
Well, I was just going to say the OSGI stuff was generally more about packaging Java code itself, and the native stuff was kind of an afterthought after, you know, OSGI cares about native because Eclipse cares about native, and a lot of what OSGI wanted to do grew out of what Eclipse was doing in terms of plugins.
But isn't that to get the IDE to work?
Well, they're still hoping that will happen someday.
But I don't care about the IDE. I mean, I use Emacs and command line. I'm talking about the artifact to give to people to run.
Right. Well, and all of that stuff is subject to, they're resuscitating Project Jigsaw for Java 9, and this will mark the 4th time, I think, that they've tried to implement a packaging system after the fact on top of Java. I'm not optimistic. The JNI stuff, the principal complaint there is that it's very old and very low level. It's very assembly-like, which is why JNA, which was never an official standard, emerged. And I saw something cross the expert group mailing list that they are thinking about a new foreign function interface, JNI, JNA, plus some additional enhancements.
If you use JNA, can you get back from the C world to the Java world?
Oh yeah, absolutely.
Can.
Yeah, JNI can go both directions as well.
No, I need that, so I use JNI for that. I didn't know that JNA could do that.
I think so, but I haven't looked at JNA in a long time.
Yeah.
JNA was very strongly influenced / inspired by some of the .NET P-invoke stuff.
Yeah, I thought that, because I looked at some JNA, sort of hello world for JNA,
Yeah.
and it had you extending like classes, like a class called library, and it all seemed very Microsoft-y, and it kind of scared me.
Well,
I just want to address, if I've got to write adder.sum, I'm going to go and write adder.sum. I don't want to be inheriting from some class library that's trying to help me out, but in the end isn't.
so not all things Microsoft are bad.
I didn't say it was bad.
Yeah.
I didn't say it was Microsoft.
He said he was scared.
You're scared. There's support
I'm
groups.
scared to turn a Windows machine on.
There are support groups. You can get help for that.
Yeah.
The JNA stuff is mostly geared around the act of going from Java to native code, because that's what a significant majority of the people using JNI wanted to do. And having to write those C-based trampolines was a pain, and they were always the exact same thing.
True.
And JNA automated that through the use of some annotations
Yeah.
and some runtime metadata, what the library would give you. I think the library class was intended to manage the act of opening and loading. You know, instead of doing system.load library,
Yeah.
you just had to instantiate the library thing.
Okay.
I think it's
Yeah.
been probably 8 years since I looked at it.
Yeah.
But, you know, in that respect, again, it was, you know, they weren't copying Microsoft technology as much as
Yeah.
trying to take what Microsoft had done and improve it in some respects.
Right.
Because there are some warts with p-invoke over in the .NET space too that we could go on and on and
Yeah.
on.
I mean, like I say, I didn't go the JNA route because I kind of was comfortable with JNI, and my Java to C interfaces are fairly small in number, so I can deal with the pain of writing it by hand, if you like. And I understand it more. If I do that, I know I'm jumping straight from Java to C, and, you know,
Yeah.
so,
Well, the biggest pain there is translating your Java types into your C types and
Yeah.
back again.
Right.
So,
Yep, I guess what that kind of highlights is there's, technology is always evolving, and we're always borrowing best practices and things that work from other projects and kind of moving them along. So, thank you, Stuart.
thank you.
So I guess with that, I can introduce our next speaker, who has already introduced himself. Ted, you about ready to go, or a couple more minutes?
yeah, give me just a couple.
Yeah.
I'd suggest we take like a 5-minute bathroom break.
Okay.
So,
If anybody wants to hit the head or anything, or
not.
or not. No, that's cool. I can talk a little bit about modularity, actually, which you kind of touched on there. So yeah, obviously, I guess there have been several attempts, and you know, JCP, the whole community process and all that stuff. There's been issues around like, you know, adoption of certain things as official send-back things or whatever. There's been some college drama, like, you know, 10 years ago or something like that. I think that's probably what Ted's referring to. I look at it this way, that, you know, it's great to have so many choices in the Java world. That can be a good thing or a bad thing, obviously. You know, sometimes too many choices can kind of overwhelm you, or you know, you don't end up with something that really works really well. So I guess it's just pros and cons. I'm just curious, how many people have heard of Docker? Just out of curiosity. Okay. Anybody using Docker? Okay, cool, awesome. Yeah, so that to me, I think, is kind of where modularity is heading personally. I mean, it's nice that we'll have that ability in the JVM. I think what would be nice in the JVM is to be the ability to break the JVM down into components and pieces and pick and choose what you want for whatever it is that you're trying to do. But in terms of, you know, DLL issues and things like that, which actually I find your solution to be very interesting in that regard also, because you're bundling everything together with the
It's really
package.
it's the Snappy Java solution that
Yeah.
I just stole the idea from and tried to generalize it.
Okay.
But yeah.
Yeah, it's kind of cool though.
Have you contacted them? I bet they're happy
Yeah,
to
I
see.
did. I did actually. The guy, yeah, I think it was a Japanese guy, and I said, "This is brilliant. I should have thought of this years ago." And I said, "Have you thought about generalising the loader part to do an arbitrary C file load?" And he hadn't, so I basically did that for my own purposes. But yeah, I said to him, "This is just great." And the GitHub project's got, you know, loads of contributions, and it's a serious piece of code. I mean, you know, if you need Snappy and you want to do it in Java, that's the thing to go to, because it's really good quality.
Is that the Snappy project on GitHub? Or is
Snappy
that-
Java project on
Okay.
GitHub. I think the Snappy C code is something that lives on Google somewhere, but if you need to do Snappy in Java, like I did exactly, and then that's the solution.
Cool. All right. So Ted, you ready to roll there?
Yeah, I think so.
All right. So Polygot programming on the JVM.
Oh, you got a power.
Cool. All right.
I think the closest one's over there, or else.
Oh, you should go right there. Just out of curiosity, how many people do use languages other than Java periodically? Stu, what do you like to use?
I have to use on.
C, obviously, but
We
that's
use, yeah, we have.
JVM languages.
Oh, no, just Java.
Okay, anybody else use any other JVM languages? Not just like for proficient on projects or whatever, because sometimes you don't find a use for language or whatever.
Yeah. I'm trying to learn Clojure, but
Oh, okay. What's your motivation behind learning Clojure?
Job security.
Yes, the obvious one.
functional programming, like if you go Clojure, they promote and almost enforce
Yeah.
the immutability of things.
Right.
Like Scala is like, if you want, it's there, nice. If you don't want it, I mean.
So the fact that they support both OO and functional style is kind of a handicap almost? Is that kind of what you're thinking?
I mean, if you want Scala because of this functional thing, get into Java 8 and install some libraries like lambdas and things like that.
Sure.
Because you're gonna get some slows down
Okay.
for nothing, I guess, my opinion.
No, that's fine. Cool.
Yeah,
We're talking
and
about opinions.
yeah, and the other thing I don't like in Scala is something philosophical. It's because Odesky is there, and he's one of the people I say is guilty for breaking Java in 5 with the generics that did nothing for us.
Oh, okay.
So it's like, you're the guy that destroyed Java. Okay.
All right. Personal decision there.
I mean, what did Java generics for us? Like, you get in the syntax sugar, anything else. Like,
No, you get strong type checking.
I like sugar.
not at runtime, like compilation time.
But the compiler can catch a lot of the errors that you could have at runtime at build time. You would not want to go back to Java 1.4, believe me.
Vectors?
Until someone make a cast and then return me something I think it is.
But then you've got to hope the cast works. You're better off having the compiler check that.
Yeah, if I had control over all the code, I don't even know, don't need that much, that thing. But if someone else is doing some aggressive cast and send me something that I think it's a list of integers, and they send me something that has a string, I have no way to check that at runtime.
It's the old type safety static and dynamic kind of issue.
I
How do you deal
mean,
with it?
they have the opportunity to make it right, and they didn't.
Now, hindsight's always 20/20, right?
That's because they wanted to do it in the compiler and not change the VM. The VM doesn't know about generics.
Right, you're right. Right, and the VM is dynamic, and that's the way they want
But
it. So.
you have to understand that blaming Odersky for that is kind of like blaming Oppenheimer for the nuclear bomb.
Yeah.
He tried very hard to convince the people, the powers that be, that this was a bad idea, and was outvoted.
Yeah.
Odersky worked on GJ along with a couple other folks, including like Philip Wadler, who's one of the big Haskell guys and whatnot. I mean, and there they were limited by the fact that they specifically wanted to implement generics just at the language level, because when you're outside of Sun, you really had no capacity to modify the JVM, because remember, this was all still pre-open source Sun days. But the Sun guys did, as I understand it, I was not working at Sun at the time. I've never been part of Sun Microsystems or Oracle, but from talking to some of the guys who were, John Rose and so forth, they examined what it would take to put generics into the runtime along the lines of what Microsoft did with the CLR. And they concluded very bluntly that Java 5 would have had to be, its ship date would have had to be another 2 years out. It was that big of a enhancement, change, fix, refactoring, whatever you want to call it. And, that was one of those, we have a choice between 2 features, right? Generics inside of the runtime or shipping. And shipping is a feature. So they made a hard choice. I don't like it. I'm with you on this. I would much rather reified types make it into the JVM. But even today, I mean, okay, so Java 5 didn't have reified types, but what about 6, 7, 8, or 9? And it's still not coming for largely the same reason, right?
And the most time we have more code bases, the harder it gets.
Sure, but at a certain point, right, that train has left the station, and, A, blaming Odersky because he said the train should go this way and it went that way. I mean, if you don't want to like Scala, like it for a reasonable reason, right? Or dislike it for a reasonable reason. Dislike it because, there isn't a functional feature that Odersky doesn't love and wants in Scala, right? I mean, implicits are a great reason to hate Scala. Don't hate it because of Odersky. I mean, come on, that's like hating puppies. Just a bad
Yeah, that's just a secondary thing. The primary thing is that you have both things and not, it's like C++, you end up using a subset of the language, right? It's like, okay, let's all use Scala and use the functional stuff, okay? If I see a code without using the functional stuff, I'm gonna throw you a phone at you. I mean, you can have a language that encourages
anytime team members are throwing phones at each other, I'd argue that's your bigger problem. I mean, there are a lot of people who have looked at Java and only use a certain number of the features inside of Java. You can say the surface area in Java is smaller and therefore, there's less that we have to exclude, right? But I knew one company I worked at back in the late 90s that was doing Java that explicitly forbade the use of the ternary operator. And when I asked them why, because I had some code that used the $:: operator and they rejected it as part of the code review, and I said, why? And they said, if else is more readable. And I said, well, that's true, but that only because it's more verbose, not because it's necessarily more readable. And we argued for a little while, and it's their code standard, so I'm just going to write code the way they want it. At the end of the day, you can look at the way Scala writes code, you can look at the way Ruby writes code. There are idiomatic ways, and then there are, supposedly non-idiomatic, more verbose ways. Scala has some interesting idioms to it. Do I choose to use .fold left as a method name, or do I choose to use the /dot that they identified as a fold left operator? Idiomatically, most Scala developers today prefer to use fold left rather than the more terse version, because that's kind of the way the community has evolved. But that's true of any language, right? I mean, you look at C, right? Is there a whiteboard marker here? You know what?
Yeah.
Right?
I love those.
What is that in C?
String concatenation. I think.
String copy. String copy, right? Assuming I have two character pointers P and Q. Sorry, it's not equals, it's that. See? I wrote it wrong and nobody noticed. That's idiomatic C, right? You should have picked up on that. That's idiomatic C, right? And people who've been living in the C world, right, long before we had all of these libraries, things like, stir copy, come on. Real men do that, right? Is that better or worse? There's a certain amount of, every language comes with its context. Every language comes with its idioms, right? People routinely make fun of Java because only in Java do we have builder, factory, builder, implementation, 2. Right? Because we choose to abstract everything, because we want to be able to do these runtime replacements all the time, right? That's idiomatic Java, right? We are searching. Java programmers, I am convinced, are in a contest to create the world's longest class name. Look at some of your Spring code. Look at some of your Hibernate code. Look at all of the different implementations and the interface. Just look at the collection classes, right? Right? Linked hash. Was it linked hash map I was working with? Because that is in fact, that's coding. That's telling me how this thing is implemented, right? Right there in the class name. Some people will say, oh yeah, that's verbose, but that's clear, that's documented, that's self-documented code. Other people will say, dear God, why do I have to type this thing out over and over and over and over again, right? This is actually, one of the things I've been mulling over in the back of my head for several years now is what defines good code, right? Some people will look at this and say, this is good code. It's terse, it's idiomatic. Anybody who's familiar with the language will know exactly what I'm trying to do here. This is good code. Those of us who are not steeped in C will look at this and say, oh my God, this is the worst thing that has ever been created, right? This is terrible. I can't imagine anybody actually thinking that this is correct. And then we go and start using our 90-character implementation names and say, this is good code. And C programmers, who, by the way, instead of being paid by the keystroke, they're paid by the non-keystroke. Right? A C programmer, the way you pay them is, here is a pile, $200,000. Every keystroke subtracts from it. That's your yearly salary. Right? So we support stuff like that. This is good code to them. Right? There's so much context and idiomatic that idiom that goes into each of these languages that if you're an outsider standing outside of that community looking at what they do, you're going to say, of course, this is stupid. Just like there are people who look at America circa the second or third week of January, or now the first week of February, and say, dear God, all this money just to watch a bunch of men running around after a pig that has no bones or blood or meat anymore. This is stupid. Why? I mean, billions and billions, trillions of dollars spent on this, right? The fact that we are arguing over whether the balls were inflated correctly, and the jokes just write themselves at that point, right? But unless you're an American, right, it makes no sense to you. Just like America looks at, although to less today, watches all these people running around chasing after a round ball that looks like a cow, and we look at that and say, that's stupid. I mean, just pick the damn thing up with your hands. Why you only got to use your feet? That's just dumb. And then you've got all those guys who talk funny and drink tea who are trying to play baseball, but they're holding the bat at the ground. Excuse me. It all depends on where you're from. It's very contextual. It's very idiomatic. So.
Also,
yeah,
UKIP is only one letter away from idiot.
You can, I mean, absolutely, right? And you know, whether idiomatic is good or bad, you know, at the end of the day, it is, right? The way in which we approach things in Java and the way in which C++ guys approached it was a product of their time, right? You walk up to JavaScript programmers today and start talking to them about patterns, right? You start talking to them about the Fowler book, you start talking to them about the Getting a 4 book. Many of them have no idea what you're talking about because that's not a part of their culture. It's not a part of their idiomatic environment. And you can say, well, that's dumb. Why don't you guys, learn something, right? But at the same time, if C++ guys start coming to Java guys talking about, efficiency of memory allocation, Java guys will say, well, why do I care? The runtime takes care of that. Well, you care because cache hits, cache misses, all of this good stuff. The Java guys are like, I don't care. Just buy a faster processor. What's your point, right? What's your problem? Context. It really all depends on context. That becomes a significant factor when you're trying to incorporate all of this stuff, right? Yeah, I think that'll be my segue into my talk. It's all about context.
You can do like a stand-up for programmers and
Stand up for programmers. Actually,
speak like that for hours. I can be here like 5 hours here until talking.
do you see that one over there slumped in the chair, right? Playing with his phone? That's my eldest, okay? They are trying, my family is trying to convince me not to talk so much. And you are encouraging me to talk more. So you may have to, take it up with him.
You've just kind of given up.
So there you go. Yes, as soon as programmers start frequenting bars and nightclubs, I may take that up as a second career, but I may have to go to user groups and do my stand-up there instead. Okay, speaking of multiple languages and so forth, this is me. I am the CTO of a consulting company called iTrellis. I've written a couple of books. I have a blog. I have a Twitter account. I have a website. Yeah. And that's, usually this slide is the one that people care the least about, so we move on. In many respects, the whole polyglot thing, it's had kind of an interesting, ride, an interesting run. Back in 2006, Neil Ford officially coined this term polyglot programming, right? Polyglot is Latin meaning poly-mini-glot languages. The idea is incorporating multiple languages together to achieve some result. There's actually a joke about this. What do you call somebody who speaks multiple languages? You call them, of course, a polyglot. What do you call somebody who only speaks one language? An American. And in some respects, the polyglot thing was going to be the heralding event that was going to usher in the whole DSL craze. If you remember, Martin Fowler was very, very interested in domain-specific languages and whatnot. And Martin wrote a book on domain-specific languages along with Rebecca Parsons, and Neil contributed as well because they all worked together at ThoughtWorks. And this goal of all these different tools, right? It really centers around the whole, you know, hammer, nail, screw, screwdriver kind of thing. If you only have one tool, all you will ever use is that one tool. All you ever use is that approach, that mindset, etc. And in many cases, that's, you know, we can certainly write any code you want in Java, but there are certain languages that naturally lend themselves to certain kinds of solutions, and we should, in keeping with the best spirit of Java, we should, you know, use the best of breed. Grab the tool that's right for the job, et cetera, et cetera. In the years since, the whole polyglot thing has, it hasn't taken over the world, certainly, although we have discovered a new love of the dynamic language. Ruby came along, and in many cases opened a Pandora's box that said not every bit of code we write has to be statically type checked. And then, on the flip side, because we were already familiar with tools like AspectJ and aspect-oriented programming and whatnot, and what they could do for us, when the functional guys came around and said, all you dynamic guys, you don't get it. What you want actually is a compiler that can do more in the way of type checking, not less. Then when Haskell and those folks came around to try to give us some better guarantees about our code, including type system that has a lot more than just, you know, is this of the right type, but actually being able to infer the type throughout the rest of the code, etc. By that point, the genie was well out of the bottle. And we had, you know, hundreds at one point of different languages running on top of the Java virtual machine. That also opened up the door to a bunch of other ideas in many respects, because now all of a sudden, if we're going to start questioning, for example, the idea that there is more to the world than just object-oriented programming languages, the fact that other approaches, other ideas are also legitimate, then that also implies that we may want to actually store this data a little bit differently. And some of this was the NoSQL movement, you know, first Couch and then Mongo, and then again, the geyser exploded, and we have several hundred different quote-unquote NoSQLs now flying around the world. And on top of that, then Microsoft and Oracle have basically given up their quests for world domination, at least through programming languages. You know, Microsoft kind of came into the whole, you know, .NET world thinking that, yes, we are going to produce something that will eventually take over the world, just as Sun came into it with Java, saying, yes, we are going to create the best programming platform and thus take over the world and render the operating system obsolete and therefore allow everybody to migrate away from Windows over to Solaris. And that plan didn't exactly work out for them. What we ended up with was Java and .NET more or less splitting the enterprise world between them. And then Dave Thomas came around and started talking about Ruby. David Hannemeyer Hansen came around and started talking about Rails. Everybody realized that, you know, a web app doesn't have to consist of 47 source files and 27 XML configuration files, and said, wow, this convention over configuration thing is pretty cool. So then Rails started eating into that space, and by the time we realized that the cat was out of the bag, there are thousands of different language platform, operating system, database combinations out there. And so, polyglot is kind of the term that Neil coined. I actually prefer the term polytechnical. The fact that we want to take advantage of various tools to their best effort, to their best effect, because this image that we have that you can in fact write code using one language has really never been the case. From the earliest days, it's been a polyglot world. In some cases, the code that you wrote was perhaps in one language, But there have always been these different languages running around, and they have always had various ways of interacting with one another. As far back, in terms of modern programming, right, reaching back to the 60s may seem like a cheap shot, but if we go back even to the late 90s, Dr. Dobbs did an article, back when Dr. Dobbs was a magazine, moment of silence. Dr. Dobbs did an article talking about little languages, the idea of being able to compose all these different pieces together to create a coherent whole. The Unix shell tools for years have had this ability of composing things together out of small programs. Sed, awk, grep, bash, etc. Just stringing them together to create the various bits that you needed out of smaller bits. This notion of program composition. It's always been a polyglot world, particularly when you started talking about where was your data from your program going to live, right? SQL is obviously the biggest one in that space, but even go back before the NoSQL explosion, go back before the great relational database heist, where they just took over everything in data. There's a whole bunch of different storage technologies and configuration and so forth. It has always been a poly world. And even if you say, well, okay, multiple languages, but we've always had multiple platforms too, right? I mean, we obviously can talk about the operating systems and the fact that there's never been a unified operating system. But even in terms of the various elements that run on top of those operating systems, there have been efforts to create platforms above the OS, right? Microsoft created one called the Component Object Model, COM, for all of their native code to try to talk to one another. Back then it was C++ and Visual Basic and Delphi and a couple other languages. Sun came around and did the Java Virtual Machine. That was just the latest of many different attempts. And then Microsoft duplicated some of that effort and innovated on it in some ways with the CLR. And today we're seeing new platforms emerge, right? The guys writing Perl tried to create their own virtual machine called Parrot, and it works relatively well, although Perl itself, I think I read somewhere recently that Perl just recently celebrated the 14th anniversary of Perl 6's announcement. I would offer a moment of silence for Perl, except I hate Perl, so I'm not going to bother. There's always been these different platforms, and so I've kind of come to this idea that Polytechnical is made up of 3 different polys. There's polyglot, many languages, polypreclusio, meaning many different storage, and polycrepido, meaning many platforms or foundations. Besides which, it just sounds so much more impressive when you do them in Latin. So, specifically here, I'm talking about polyglot, and in particular, it's really nice because the Java Virtual Machine provides such a nice open base platform for people to experiment with different languages. At one point, there was a web page, languages for the Java VM. It was the first hit in your search engine of choice. There were over 150 links to different languages that were running on top of the JVM. The Java Virtual Machine was a great place to be experimenting with creating new languages. That's part of the reason how we got Aspect J. Again, the world has always been a polyglot one, right? We basically settled on a standard as far back as the Unix world. We said as long as you knew how to consume and produce a C endpoint, right? As long as you knew how to consume a stack frame passed to you in C, right? Let me just set up the stack the right way, jump to your entry point in assembler, and you could consume that as long as you put the result in the right place and jumped back, then yes, we could interoperate. And that still today is an open standard across all of these different Unix platforms. This created a degree of interoperability that, again, is still in use today. You start looking at all these different languages, Erlang, Ruby, Java, right? Talking about JNI, that's all a C-based interoperability endpoint. When you create a JNI shared library, you're declaring it using the C standard. You have to expose it using C APIs, including the prefixed underscore. Okay? All of this is based around C. When the web came around, the web introduced a new layer, became a new interoperability layer. Obviously, we could do HTML, CSS, and JavaScript on the front end, XML for doing configuration, SQL for data storage. I mean, just forget your implementation language. Just look at these 5 and tell me that you're only programming in one language, right? And this is before we even get into whatever your implementation language of choice is. when the JVM came through, one platform, many languages, right? Oh no, wait, I'm sorry, that's the Microsoft mantra. The Java mantra was many languages, no, many platform, many operating, you know what, they both did the same thing, right? Sun, of course, for many years said there's only one true language and it is spelled JAVA, and it runs on this thing that runs on top of all these different operating systems. But for all intents and purposes, Java is introduced at Comdex in 1995. By 1996, there were already alternative languages running on top of the JVM. In particular, Per Bothner, who was one of the early guys to adopt the JVM, he produced an implementation of Scheme on the JVM called Kala, right? And as a matter of fact, although nobody knew it, a gentleman was working on an implementation of meta-object programming based on his experiences with the Common Lisp object system. And he decided he wanted to try to do this with a more statically typed language because he was watching people get themselves into trouble with too much meta-object power. And so he starts working on something and then later decides to do something slightly different. His first effort was called Cool. His second effort was called Aspect J. And that's Gregor Gonzalez. And he releases that upon the world in 2001. Meanwhile, James Strachan, everybody's favorite open source wingnut, he's out there looking at Ruby. Because Ruby is, it's been around since, I don't know when Mott starts working on Ruby. I think it's in the mid-90s. Ruby in some ways predates Java. And James looks at Ruby and says, wow, these are some really cool ideas. I'd love to see some of these ideas incorporated into Java. So he starts working on a language that he calls Groovy, because Juby and Rava just don't sound good. But Groovy sounds kind of groovy. And so he's working on this language and never actually finishes it. At one point, he's basically done with it. He said, yeah, I experimented all that I really wanted to. And of course, Guillaume and Grain came along and said, well, do you mind if we pick this thing up and run with it? And he said, yeah, sure, mate, go for it. And Groovy was thus born, shipped 1.0, the Groovy Foundation, blah, blah, blah. You guys kind of know the story from there. The CLR, of course, followed suit in 2001. Microsoft announces the CLR. They are explicitly talking about multiple languages on top of this virtual machine platform. Of course, Microsoft ships a couple to begin with. They have C#. They took Visual Basic and flipped it over to a .NET version, thus pissing off everybody. They pissed off the Visual Basic folks because it wasn't really VB anymore, and they pissed off all the C++ folks because now the VB players are going to come play in the C++ programmers playground. And just to make sure that the C++ guys got really pissed off, Microsoft released a version. First they called it Managed C++, then they later called it C++ CLI, and this thing is so complicated that Stan Lippman, one of the original C++ programmers in the world, Strustrup was 1, Lippman was 2. Stan Lippman stands up at a conference and says, I've tried to do an array, what do you say, a pointer to an array to a pointer of an array in Managed C++, and I couldn't figure out the syntax. And this is a guy who's working on the compiler. Okay? So these all ship with CLR 1.0. They also actually had an implementation managed JavaScript, which is better off left dead. But more importantly, they engaged with the community. There was actually a project that they were running under very strict NDA called Project 7, working with various universities to make sure that they could get languages running on top of the JVM beyond the stuff that Microsoft wanted to ship. One such language was called Mondrian, which was sort of I don't want to say an enhancement, but it was a take on Haskell and so forth, other functional languages running on top of a managed environment. And as a matter of fact, one of our favorite characters, Jim Huguenin, right? How many of you know Jim Huguenin's name from his work in Jython? Right? Yeah. So if you've done anything in Jython, you know Jim, because Jim was the principal Jython maintainer for many, many years, right? This is Python running on top of the JVM as a scripting language. Jim actually set out to write a paper for a conference entitled, quote, Why the CLR Sucks So Bad for Dynamic Languages. And as his sort of evidence, he was going to produce an implementation of Python that ran on top of the CLR. And he did. And it actually ran as fast as C Python. He stunned himself. He was shocked. He said he spent like a week or so
trying to prove that he was wrong with his benchmarks, that this just couldn't be right. There had to be a flaw in his benchmark somewhere. And this was before he did any optimizing in the Python interpreter. And finally, had to go back and during his presentation at the conference say, this was the title of this talk, and I'm here to tell you that I was wrong. He did a slight revision of the source code for what would later become known as IronPython. And later Microsoft hired him and made him the head of the Microsoft Dynamic Languages team that produced the DLR, which is a kind of CLR specifically aimed at dynamic languages. So, you know, we've certainly had this space. We've had all these different platforms that make it very easy for us to, in fact, embrace all of these different tools. The modern way, right? If you're doing stuff today, chances are you're thinking about some sort of single-page application, right? Angular, Durandal, something like that, that in turn makes RESTful. Actually, I don't like the term RESTful because that just is an incite to religious debate. So let's just call it web or HTTP APIs. But you make them using HTTP back to a server, which typically gives you some form of JSON back. I mean, the opportunities for interoperability here are legion. And then when we start talking about microservices, so instead of creating this really monolithic, huge collection of stuff, we slice it up into more domain-specific slices, call those microservices. Fowler and the ThoughtWorks folks are really, really big on that. And then, going back to what Nimrod was saying, we deploy these microservices into these Docker containers, and suddenly I don't care what your service is implemented in, as long as it implements a HTTP API, as long as I can get at it via HTTP and some JSON, you know, or even if you're old school, HTTP and some XML, let's do that. I can consume it. I don't care what your implementation is. And you know what? If you want to write it in Erlang, if you want to write it in, God help us all, if you want to write it in COBOL, you can do so, right? Because, I mean, I'm gonna say it out loud, and unfortunately Nimrod is recording me, so I'll have to ask him to edit this out later. COBOL actually does have a place in the world. And it makes a certain amount of sense for that COBOL code to continue running. I feel like I need to wash my hands now or something. Okay? The point is that this polyglot thing is definitely not going away. I mean, it's in many respects, all of these different technologies are only going to conspire to make it worse. And the requirements for us to have a polyglot space, right, whether we're talking about an operating system or a platform or whatnot, the requirements for Polyglot are really straightforward. Do you have some sort of communication medium? In other words, can A reach B? Right? Now, if they're both running on the same machine, by definition the answer is yes, because they're both processes. A knows how to reach B, because they're both inside the same OS. But the second thing is some kind of common data frame format. Right? Again, for most operating systems, for the last 40 years, that common data frame format has been the C-style stack frame. It hasn't needed to be anything more sophisticated than that. This is how parameters are expected. Oh, by the way, depending upon what the actual operating system is, depending upon what the hardware architecture is, right, integers may need to start from here and go this way, or they may start from here and go this way, but that's a part of that understood stack frame format. And the return value needs to be on the stack in this place when we hand it back, and you know, the end. It's a very simple, straightforward exchange mechanism. So now, as long as you conform to that, you're good. You can plug in. And this is why, if you look across the breadth of all of these different languages, whether they implement a platform or if they simply talk to one, all of the FFIs, the foreign function interfaces, they all rely on that C basis, because that's been the modus operandi. That's how we've enabled this polyglot environment for 40, 50 years. Now, today, we're starting to see some of this stuff combined with HTTP, right? HTTP gives us a communication channel. The data frame format, we originally thought that would be SOAP. This was the whole web services promise, right? We thought SOAP was going to be the thing that would, in fact, enable all of these different tools to coordinate with one another at a higher level. And we're sorry. I mean, SOAP itself was, you know, if you look at SOAP, the actual specification, it's not SOAP's fault. SOAP is really just a data framing format. Here's where headers go, here's where your payload goes. That's all SOAP really says. It's WSDL and XML schema that really kind of screwed the pooch on this idea. And the fact that we tried to put a type system on top of all of this. The C stuff never really, defined a type system, right? If you want to get you want to get an array of characters, it's just an array of bytes. How you choose to interpret it is entirely up to you. Which created some angst, because now if I want to hand a C-style string over into some VB code, I have to figure out who's going to map to what. So it's better if we have a little bit more definition around that data frame format, but doing so then constrains everybody to, you must speak my type system. You must understand the kind of code that I want to deliver. In the Java world, right, we actually have defined this because we're running on top of a runtime and we have some defined primitive types. You either conform to the Java type system or you're not running on top of the JVM. The end. It's just there is no other way to do it. Ditto for the CLR. They were actually a little bit more explicit about it because they created the common language standard, right, which is essentially these are the types that you must understand if you're going to run on top of our platform. Anything outside of this you can represent however you want, but these are the types that you must understand in order to run on top of our platform. The JVM spec is that for the JVM. You have to understand all the primitive types, you have to understand objects and inheritance, and anything beyond that is totally up to you, but you're not guaranteed that it will be understood outside of your particular language, etc. It's also helpful to have some kind of identifiers or metadata format.
So if you're producing like a shared library, I can find your particular function as opposed to having to jump to some location in memory and hope that it's the right place. Every shared library system on the planet that every operating system supports exports at least the name of the thing, even if it doesn't export anything else. This is basically what Windows does. In the name, it actually encodes how many parameters are supposed to be there. So when you're looking at, message box, the operating system actually exports it as underscore message box A at 20, meaning I'm expecting 5 parameters. And by the way, this is an ASCII version of the API, so therefore you must give me ASCII-centric strings as opposed to wide character strings, Unicode, etc. As long as you know the name, as long as you know the frame format, as long as you know how to get at it, we have Polygot. And in the grand scheme of things, this is not a difficult checklist to meet. This is only going to get better or worse, depending upon your perspective, as time goes on, because now people have started to understand the value of these virtual machines. Why do I want to bother thinking about how memory allocation should be done when there are guys at Oracle and there are guys at Microsoft who are spending all day thinking about memory allocation? That's all they're paid to do. Am I ever going to be able to top that? No, not ever. Unless I happen to work for Google and I want to try to build my own virtual machine and ship it on top of a mobile platform. In which case, hey, you've got money to burn, do whatever you want. Right? Let's play around with self-driving cars while we're at it. Oh no, wait, they did that. Crap, I'm gonna need a new example.
Drones.
What's that?
Drones.
Yes, drones. Drones that will deliver groceries right to my door. Oh crap. Anyway, I'm actually surprised that Amazon hasn't started flirting with languages. I think it's just a matter of time. Somewhere in the next 5 to 10 years, Amazon's going to release a programming language. You heard it here first. All right, why would I want to do this? I mean, because let's be blunt. When we start talking about this polyglot thing, we are definitely adding complexity to the whole story. I mean, for starters, I have to think about some of my build system stuff, right, like Stuart was talking about earlier. I have to think about how am I going to build this C code alongside my Java code. I'm going to have to think about who do I train? How do I incorporate these folks? I have to think about where the boundaries are going to be and which parts are going to be supported by which other parts. I mean, I can't just walk up to this thing willy-nilly because either I'm going to have to carefully select developers that will fit on each of these parts, right? Or I'm going to have to cross-train all of my developers in all of the languages that will be supported here at Company X, right? And that is not a trivial undertaking. I mean, hey, welcome to your first day. Monday you'll be learning Java, Tuesday you'll be learning Groovy, Wednesday you'll be learning Scala, and Thursday and Friday you'll still be learning Scala. The following week, you'll be learning JRuby, we expect you to have mastered all of these within a month. And then starting in week 3, we'll get into our NoSQLs, right? I mean, that's not feasible, right? Because today, if you're a Java developer, right, your first day is, okay, we're gonna teach, well, you already know Java, and you should already know Spring. Oh, you don't know Spring? All right, we'll teach you Spring. That'll be on Monday, and Tuesday, and Wednesday, and Thursday. And then Hibernate, because you know SQL, right? Okay, good, you know SQL. Well, you know enough SQL to get yourself into trouble. Okay, so we'll teach you the SQL that we use at this company, meaning no nested outer joins ever. And we'll teach you Hibernate. And next year, when you're done learning Hibernate, I mean, in some respects, if you start looking at what the Java stack represents, there is a boatload of stuff there. I mean, think about all the different Java technologies. If you are a brand new University of Washington graduate, and you have learned Java, you have faithfully created your Swing application, right? You are ready to go into the wider world and learn how to work on these enterprise Java applications. Think about all the stuff you have to learn to work on a quote-unquote modern Java enterprise stack. I had a student, one second, I had a student today, was meeting with him because he wants to work on an honors project in the fall quarter. And he said, look, I'm interested maybe in learning some compiler stuff. I'm interested in learning how compilers work. I'm thinking about trying to like recreate a C compiler or whatnot. It's like, well, okay, there's a lot of complexity there. You got to think about parsing, and you got to think about transforming it into an AST, and then doing a semantic check, and then you have to think about how if you're going to do any optimizations, and you have to think about the code generation aspect of things. And he's like, wow, there's a lot more work here than I thought there would be. So the other thought I had is I would do an enterprise Java program. I said, go back to the compiler. You want to say something?
Well, I was just going to say all you need to learn is how to Google.
Yes, yes, because Google is the best way to program, right? So from having worked on generations of Visual Basic cut and paste programming, Google and paste programming is not much better. As a matter of fact, interesting story. I have no idea if this is true or not, but I think I heard it from Brian Getz. But apparently, they started doing some inside of Oracle/Sun, right towards the end of the buyout there. They started doing some static analysis over all of the Java code inside of the JDK, and they were finding some very interesting, specifically concurrency-related bugs that were happening inside of the JDK that nobody had found. In some cases, there were some Swing bugs that were lurking there for 10 years that nobody had found. And so then they actually started doing some analysis of all of the Java code that they found all across the internet. And interestingly enough, as a side effect of that, they realized that there was a very fundamental bug somewhere in Java, in one of the Java demo applets. I mean, very, very fundamental bug. And they discovered that same bug in 83% of the Java code that was publicly visible on the internet. I don't know the bug, I don't know the details. But it was, to them, the smoking gun that said, yes, everybody learned Java the exact same way. You start with hello world, you copy and paste, and then you just sort of cribbed it out from there. Not a big fan of Google cut and paste, thanks, or let's play Microsoft. Bing cut and paste, right? Because then it's a BCP.
How about Stack Overflow cut and paste?
Yeah, SOCP doesn't roll off the tongue quite as well, but yes, absolutely, absolutely. And unfortunately, one of the things, I mean, Stack Overflow is a little bit better about it, but one of the problems is a lot of times the context around which these solutions, these conclusions that people draw is lost as people just kind of go, ooh, code, cut, paste, cool, I can call it shipped and move on to the next item in the backlog, right? It's unfortunate, but it's going to happen, period, end of story. And the only way I can see to solve that is either to make the languages simpler or kill off all the people who do that. So would all of you who use Stack Overflow on a regular basis, please say your name loudly for the camera, along with maybe your address and the times you're alone in the house, all right? So we'll begin with you, Nimrod.
Ted Woodward, Redmond.
Dude, the NSA is listening. They've heard you do that. You're on their watch list now.
Sorry, I'm from South Asia, so.
Oh, yeah, that
By
gets you
default.
off, right? That gets you off, no problem. These are, I mean, this notion of introducing deliberately additional complexity into my system scares a great number of people. But the interesting thing is, you know, a number of us on the NoFluff tour were debating a lot of this Polygot stuff back when, you know, Neil started talking about it in 2006, and we said, look, you know, imagine that you're describing your application, your Java application, but instead of using the word framework, what if you use the word language or DSL, right? And it turns out that these two are shockingly replaceable. Think about the amount of time it would require me to learn a new language. Well, think about how long it took you to learn Spring. Well, I mean, I have to figure out how to maintain this language. Well, somebody has to maintain Spring. And it's not you, sure, you can just consume it off the shelf, but you don't have to necessarily maintain the language yourself if somebody else is maintaining that. If you built your own Spring, because there was a time when it was kind of a thing to build your own microcontainer, right? Back when container didn't mean Docker. You know, you had to maintain that. Somebody had to own that code, just like somebody has to own Spring today. You know, a lot of these objections that people raise about languages and this complexity, we have that complexity. It's still there. We've just put it into frameworks rather than into libraries or languages or something else. So, you know, there are a couple of cases just off the top of my head where we can start thinking about where this polyglot, this polytechnical approach would be particularly helpful, right? So for starters, imagine you're in a scenario where the logic is changing on a regular basis, and or the logic is actually not something that we in the IT department want to be a part of. You know, one of the classic scenarios that I used to think about, particularly before a lot of the Agile stuff became a big deal, was, all right, so, you know, you're at Amazon.com, I'll pick on them for a second. You're at Amazon and you need to run a particular marketing type special. Order today, get the Harry Potter wand. You know, order a Harry Potter, the 7-box set, get a free Harry Potter wand, but it only lasts for a week. And it starts right here on, I don't know, March 17th, the date Harry Potter 7 was released or something like that. And the marketing guys came up with this 3 days ago. They don't have time to wait for a full release cycle to put that onto the website. They need that to go in now. They need that to happen right now. Or we find that there are certain amounts of logic that we cannot predict ahead of time that are changing on a daily basis. These kinds of things happen. Or in some cases, we can't predict what we want to do. This is the classic scenario around any sort of hook API. Think about GitHub. When they instituted webhooks on GitHub, do you think they had any idea what people will end up doing with it? They just knew that they wanted to have some sort of extension point so that other people could do things that they couldn't possibly imagine today. And that's exactly what people are doing. They're using webhooks to do gated check-ins with Git, or they're using webhooks to do website deployments, or they're doing, you know, webhooks to do a variety of other things. They had no idea. In our case, running on top of the JVM or any other managed language, this is a case where scripting languages can actually be particularly helpful. Partly because scripting languages can often be a little bit higher level, right? And a lot of people have actually dabbled with, for example, JavaScript. Right? There are a lot of students who have been through college who have done just a little bit. They learned some HTML and a little bit of JavaScript, and you know, if you were to sit them down and say, hey, could you do this? They could actually make it work. Or in some cases, we could use the scripting language as an extension point to be able to implement additional logic, whether that's something that somebody in IT does, or whether that's a business analyst who's had some programming knowledge but doesn't have enough experience to be considered an IT developer, right? Scripting languages work particularly well there. And I'll give you, quite frankly, what I think is the most famous example of all. How many of you use Emacs? Yeah. And Emacs is basically a text editor with a scripting language built in.
which in turn became a lifestyle. I mean, is there anything Emacs can't do? Seriously. The fact that he has to think about it should tell you something right there. I'm waiting for the day when Visual Studio has a scripting language in it. I really am. I mean, it shocks me that they haven't bothered to do that, because so many of the plug-in architectures that they have architected would effectively become irrelevant at that point going forward. Nimmer.
VB getting resurrected, maybe?
VB getting resurrected, if they're worried about it or they want that?
No, as the scripting language.
Well, they already had VB. VB script was a thing for a long time. Yeah, so, you know, think about, I don't want Visual Studio to have scripting.
That was the joke.
Yeah.
There are a number of problems that, quite frankly, just do not fit well to an object-oriented paradigm, particularly if you have a bunch of multiple variables that are involved, right? Anybody here ever tried to rent a car? Right? It's an absolutely fascinating experience. This isn't buying airplane tickets, because I'm convinced that the airlines are just making numbers up. I really am. I really think that all of their pricing engines come down to a system.random call. Because some of it makes absolutely no sense to me. If you want a flight from, this was an absolute true statement, I was trying to fly from Sacramento to Rochester, New York, and I was looking at the pricing, and they said, okay, so flying from San Francisco to Rochester was like $550, but flying from Sacramento through San Francisco to Rochester was $250 cheaper. So we add an additional flight and take $200 off the price. Please explain that one to me.
Someone actually just built a service that exploits this and helps you
Yes,
flights.
yes.
I think he got kind of into trouble with the airline.
No, he got off. He got off. About a week ago, the judge, because United, he was exploiting all of United's routes to find the cheapest price possible, et cetera. And the judge basically said, United, stop it. What he's doing is completely fair trade and legal. If you don't like it, fix your pricing system. So, win one for the little guy there. But I mean, if you're Hertz, even if you're Amazon, right? Okay, somebody comes in and orders something off of our website. If it's over $100, they get free shipping. Or if it's under $100, but they're a silver member, they get free shipping. But if they're a silver member and do it before December 17th, not only will they get free shipping, they'll also get a replica Harry Potter one. Unless it's the second Thursday of the month and the moon is full in the House of Aries. I mean, there is a lot of these multi-variable scenarios that we have to try to account for. I mean, business rules, right? And these kinds of deep recursion, multiple variable scenarios are made for logic languages like Prolog, right? Or rules engines like Drools, which are, in essence, their own language in many respects. If you've ever looked at Drools, or if you've ever looked at Jest, which is essentially a Java implementation of Clips, the logic engine that anybody who did anything with Lisp has learned. These guys, I mean, if you ever wanted to do a Sudoku solver, right, logic languages, you can express this very, very quickly. It's probably about, 150 less lines of code. And it's all declarative, and it's all recursive, because the engine tries all the possible things and then cuts back, and whoa, the whole 9 yards. It's very easy to do in Prolog. It's impossible to do in Java. Sometimes logic is best expressed by the domain expert. This is the classic DSL scenario, right? And it doesn't have to be just domain logic. I was just talking to somebody not too long ago, because there's a financial scoring engine that they work on, and all of that code was written in Fortran like 50 years ago. And the same guy is maintaining that code in Fortran today and continuing to run it. Right? And they are completely constrained getting away from this, because it's all this incredibly mathematic scoring engine kinds of stuff, right? We could talk about the intelligence of trusting all of your analytics engine to one guy whose heart may be right? But at the same time, you certainly don't want to throw away all that code. It has to come with you from one generation to the next. As long as I can consume it from my chosen platform, I don't care if it stays in just a binary form for the rest of my natural life. The coal and oil industry out in Denver, They had, I did a class for a company out in Denver many years ago, and they just admitted point blank, they were the last Microsoft Fortran customer on the face of planet Earth. Because they were compiling their Fortran code, which all of their scientists, really, really bright guys who can look at a patch of dirt and say, there's oil under there, right? It's all written in Fortran, because that's the language they know, that's the language they love, that's the language you're only going to pry out of their cold, dead fingers. So they write it in Fortran and compile it to a DLL, which can then be consumed by anything on the Windows platform. Does it make sense to them? That is a form of the DSL. DSLs don't have to be fully English kinds of languages. Although if you really want to see what I think is probably the ultimate expression of a DSL, there is a language called Inform 7. It's a language specifically for interactive storytelling. If you ever wanted to produce your own Zork adventure, Inform 7 will do it, but you do not have to be a programmer to write Inform 7. As a matter of fact, it's much better if you're a fiction author, because the code reads like English. It is English, and the parser interprets it correctly. It's amazing. It's absolutely amazing. I so wanted to take a couple of months and dive into that parser there. And in some cases, I mean, all of that has been talking about languages, but when we start talking about data representation, storage, models, etc., I mean, not all of it fits into square tables and rows and so forth. And this is where all of the NoSQL stuff got just, wildly going. And in some cases, I mean, you kind of hope this never happens, but in some cases you inherit a team that just, for whatever reason, none of them have the same skill set. Some guys know PHP, some guys know Python, some guys know Ruby, some guys know SQL, some guys know Couch, some guys know X, Y, Z, et cetera, et cetera. And you have to, in a very short period of time, produce a working system out of this conglomerate group of completely random people, right? You don't have time to teach them the one true language that everybody will use. And so you look at this challenge here and say, oh my God, this is a disaster. This could never actually work, right? Tell that to the Republican Party, because that's exactly what Obama's IT team did. This blog entry here has what I think is probably the best analysis of all the various disparate pieces put together. I've never found any other sort of post-mortem on the Obama website. But that's exactly what they did. They had a collection of volunteers from all over the country with just the most random collection of technology skills you could ever imagine. And yet, 583 days later, not only had they built all of this infrastructure, which Obama was very quick to point out as one of the reasons why they were able to get better results from their polling and in terms of understanding where they should do their ad spends and so forth. They built a dashboard. They didn't go buy one, they built one. Ruby on Rails was great for that, but in terms of doing some of the social analysis and so forth, they were borrowing from PHP, from Ruby, from Java, from .NET. There were 100, supposedly, there's a passing reference to 100 different standalone programs that were a part of this system. 180 terabytes, 8.5 billion requests. Now, just for the moment, if you could put this on your resume, how many of you would? Seriously, right? 583 days, from 0 to he's won, we need to tear it down. Oh, and in the middle of this, your data center gets hit by a hurricane with no outage. Sandy hit the East Coast about 3 weeks before the election, if I remember the time frame. And these guys basically migrated from AWS East to AWS West with no outage. Okay, and all of that, polytechnical. They didn't have one defined architecture. They didn't have one defined database. They had some SQL, they had some NoSQL, they had some flat files, they had some of everything in this. I really, really, really want to find a more detailed breakdown in all of this. I really do. Yeah, there's a lot of stuff to this. There's a lot of options to this. It does represent some significant investment. I mean, we can talk about, the different languages, right? We've got Groovy, right? This effectively, it's a dynamic language running on top of the Java runtime, right? First appeared in 03, by now, 12 years later, 2.4.1 is the most recent release. Pivotal, they were originally, well, not originally, they inherited Groovy because there was the G21 foundation, or the Groovy Grails Foundation, later got acquired by SpringSource, who later got acquired by VMware, who then got acquired by EMC, and then they decided to spin that off into Pivotal, and then Pivotal just recently decided, you know what, we're kind of done, we don't want to invest anymore in this, and so now it's moving into an Apache incubator, presumably to become an Apache top-level project. I don't think a question of the popularity of Groovy and Grails is all that mysterious. But you know, you have, in many respects, a lot of people have looked at Groovy and said it's a better Java, right? It's a better dynamic Java, right? We don't want to have to deal with the stupid casting and all of that stuff. Let's just embrace the dynamic nature of programming, and let's just, you know, we'll write a whole bunch of unit tests around our code, but other than that, let's just get the whole type system thing out of the way. Let's make it more of a meta-object environment so I can add properties and fields and methods to the class at runtime and so on and so forth. Groovy's got a lot of goodness to it, particularly when you do some of this stuff, including AST transformations. Has anybody ever seen the Groovy tool Spock for doing testing? Oh. Anybody here like to do cucumber-style testing? No? No hands, one hand? All right, let me...
There is one here, but it doesn't raise that up the hand.
Yeah, he's like, I'm not really sure I want to. By the way, I love the t-shirt. Amelia says hi, I'm sure. Spock, unit testing. So, the Spock testing framework, it's a TDD framework, but it follows that whole given, when, then style. So, what to see? So, yeah, check this out, right here. That compiles and runs. Okay? That is arguably a DSL. When, colon, you do this, then, colon, these things should hold. This is all legitimate Groovy code. Because what they're doing is they're doing some runtime AST transformations. The Groovy parser goes through this, parses it all, it's all syntactically legit, and then says, all right, now I'm going to transform it into what should actually happen. So this is what we sometimes refer to as an internal DSL, from the standpoint that it is a domain-specific language, and it's actually executable in that language, in this case, Groovy. Right? Scala can do some similar really crazy syntactic tricks. This, by the way, is also legitimate Spock code. And I have no idea how they do this. I really don't. I mean,
What says the stack was empty? Where does it say the stack was empty at the time of the push?
I believe in the setup here, you can set up stack.
Okay.
Although I think, do they have a given block again? I guess you can do a setup block as well, right?
Yeah.
And they show over here the different blocks and how they map over to the phases.
Okay, like JUnit as a whatever the
Yeah.
setup is.
Yeah, I think if you drill down far enough through the Spock code, you end up at JUnit or something basically similar. But instead of having Java, right, we have a very, very strict syntax to work with. Your curly brace must be at the end of the line, and you must have semicolon, all that kinds of stuff. They have a very strict, I'm surprised nobody argued with that. Curly brace at the end of the line, and everybody was just like, oh yeah. The Groovy syntax is a little bit more forgiving. So for example, down here, Groovy actually has a couple of cases where you can leave out the dot entirely, stack push. They'll infer the dot there. Scala can do the same thing as well, right? As a matter of fact, I know Scala, I don't think Groovy can, but Scala can in fact ignore the parentheses here as well. So you would say stack push lm. And if you do some syntactic magic, you can actually say push lm into stack, if into is just some kind of a joiner that says I take these two things and apply it to stack. There's some incredible syntactic flexibility here. And when you start doing some of these little tricks,
tell me that you couldn't put this in front of a business analyst. I mean, seriously, if these are people who have some level of analytical ability, tell me they can't figure out what's going on here. Yeah, okay, why do I have to use 2 equal signs instead of 1? Well, for the same reason that all counting begins with 0 and not 1, because we're programmers and we have to do it differently. You know, job security, whatever, right? There are some quirks you will have to learn, Mr. Business Analyst, but this is, right? This is what Groovy enables in terms of AST transformation. JRuby can do, well, Ruby, and then from there we go to JRuby, Ruby running on top of the JVM, can do similar kinds of syntactic transformations. Anybody who's ever tried to build a Java EE web application and then started playing around with Rails, usually doesn't come back. And this is what happened to a lot of the speakers on the No Fluff tour. A lot of them started talking to Dave Thomas, a lot of them started looking at Rails, and the next thing you know, Bruce Tate is writing a book on Rails talking about how Java is so clunky and obsolete. Right? And of course, branded as a traitor by all of the folks in the Java land, and then later we embraced all of those same ideas and called it Java EE5. So, there are some really powerful ideas present in each of these languages that we can go ahead and make use of, right? Directly in some cases, because they all run on top of the JVM, right? Scala, we mentioned Scala before, right? Scala has a number of quirks to it. It's also got a number of really powerful things to it in terms of, you know, functional programming and whatnot. And Odersky definitely has a lot of familiarity with creating languages, right? Not only did he do Scala, but the previous implementation was a language similar to it called Funnel. Right? And the big difference between Funnel and Scala, at least between Funnel and Scala 2.0, 2.1, is Funnel didn't have anywhere near the library support. He was expecting people would just write the code by hand and realize, wow, I really need more of a library to support it. But before that, he did GJ, and before that, he created a language called Pizza. The Pizza compiler, by the way, is still out there, and you can see vestiges of Scala in the Pizza compiler. You know, Pizza C is very, very similar in a lot of ways to Scala C. And you know, as long as you're willing to compile code that runs on a JDK 1.1 JVM, you could use Pizza today if you wanted. The source is out there. But he introduced generics in Pizza. I asked him once why he called the language Pizza, and he said, oh, because that's what goes with coffee is pizza. I said, no, dude. Pizza goes with beer. He's like, oh, you Americans. Anyway. I'm not going to, Nimrod's going to have the slides. You know, there's some Scala basics in here if you want to just kind of rip through these. A lot of these ideas are making their way into other languages, including, by the way, JavaScript. If you've not looked at JavaScript 6, there are some of these kinds of ideas, like for comprehensions and whatnot, are showing up in JavaScript. Right? That's the other really big reason. Let the Scala stop, please. Where did it stop here? There we go. You know, a lot of these languages will influence your thinking. They will influence the way you view the world. You will never look at Java the same way. Specifically not Java 8, now that we have function literals and streams and whatnot. You'll never look at that stuff the same way once you've spent some time with Scala and its functional approach. Groovy still does some of the same stuff as well. And so, you know, you can go either the dynamic or you can go the static, but either way will get you into some of that space. JRuby, of course, is a full-fledged Ruby 2.2 on the JVM, and Charlie Nutter, is Mr. JRuby, and that guy has forgotten more about the JVM than I will ever learn, because he has made, as close as he possibly can, JRuby run exactly the same way as Ruby does, on top of MRB. It supports Ruby gems, which leads to Ruby on Rails. I mean, JRuby on Rails. You can actually take Rails code, for the most part. If you have some C extensions of your own, you may have to figure out how to, adapt those, or you may have to write some JNI code or something along those lines. But most Ruby programmers don't deal a lot with C extensions anyway. And to take your Rails application and run it on the JVM, A, make sure JRuby is there. B, make sure Tomcat is there. Okay, well, those are pretty straightforward, 2 installs. then use JRuby to install Rails on the machine. And if you already have an existing Rails application, the gems will already be there, they'll be present in the gem file, so you just have to do like a bundle install. There are two adapters that you will need specifically. Presumably you are talking JDBC, your database of choice, you will need an active record JDBC adapter. Right? MySQL is of course one of the more popular ones, but there is an HSQL, PostgreSQL, Oracle, MSSQL, etc. This is for the Rails side to know how to configure it, and you'll need to specify the JDBC URL to use. The other thing you'll need is a JRuby OpenSSL adapter, because this is some of that native code that Ruby didn't implement by itself. So we need a Java-friendly version of that. And then lastly, you pull down a tool called Warbler, which basically transforms your Rails application, packages it up, pre-compiles all the Ruby code into .class files, bundles it as a war, ready for deployment into any Java server of your choice.
Okay? And that's where Warbler is found, and it talks about the different plugins, how it modifies your rake file, etc. It's a blank slate. It's a brand new world. This whole polyglot thing, it reeks of complexity. It reeks of you couldn't make up your mind. It reeks of legacy. The fact of the matter is, though, it's already a polyglot world. Embrace it. You're not going to change it. As a matter of fact, particularly out in the JavaScript world, they're embracing it in a huge way with all these different language transpilers. There are all these different languages that will compile, quote unquote, although the proper term is transpile. They're transpiling into JavaScript. Right? So you can take CoffeeScript, which is kind of a Ruby-esque, and turn that into that JavaScript that can run in any JavaScript interpreter, any JavaScript 5, ES5 interpreter, which is everything. There's TypeScript, which is kind of a harbinger of what we're seeing in ECMAScript 6. TypeScript comes from Microsoft, but it's all running on top of and inside of the JavaScript community. So if you've got Node, npm install TypeScript, and now you have a TypeScript compiler, transpiles into JavaScript, off you go. And, by the way, I don't know this for a fact, Oracle at one point was working on kind of a JRuby-esque for JavaScript on the JVM. They already have a Java interpreter inside of the JVM. It's called, well, it used to be called Rhino, but they're replacing it with one called Nashorn. That's been there since Java 7. And it's a much better implementation of JavaScript. And they're going through the exercise, or they were, I don't know if they still are, of what it would take to allow JavaScript NPM packages to be able to run on top of Nashorn, on top of the JVM. So if you're a Java developer, you're literally looking at the world like, okay, I've got all of my Java applications, all of those libraries, all of that ecosystem available to me. But if that's not enough, I've got all of the various languages that compile onto the Java virtual machine, right? Prolog, TU Prolog, is a Prolog implementation that runs on top of the JVM. So if you want logic languages, I've got those that will run on top of the JVM. And then I've got JRuby, which opens up the entirety of the Ruby ecosystem to me. And if Oracle actually finishes this NPM adapter tool, now I've got the entirety of the JavaScript world open to me. And by the way, those ecosystems include at least 6 different excellent Ready-based rules engine implementations that I can think of, which is one of the most obscure things you would ever expect to find on a platform. There's a version for Node, there's a version for Ruby called RuleB, and there are 2 implementations for Java, and the list goes on and on and on. You're running on top of the JVM, you have a lot more open to you than just Java. Let's use it wisely. The end.
Cool. Questions?
People want beer.
All right. Thanks, Seth. I'm impressed. Thanks for sticking around.